After we choose and state our scales, the third step in plotting graph is calibration of the axis. We have to calibrate the axis of the graph page. Both axes need to be calibrated, but you may ask, what does it mean to calibrate the axis? And how is it to be done? That takes us to lesson number 13, and that is calibration of the axis. Follow me as I use an existing table and a graph page to explain how to carry out calibration of axis.
Step 3 is calibration of the axis. We are going to calibrate the x-axis and the y-axis. What are we going to use to calibrate? In fact, to calibrate simply means to give a mark to an interval. That is, to assign a value to every interval. That is what it means to calibrate. With what are we going to calibrate? We are going to calibrate with those scales we calculated. How do we calibrate it? We calibrate arithmetically. What do I mean by that? What I mean is this. If 1 unit corresponds to every interval along the x-axis, what it means is that from here to here is 1. Another one, we make it this place 2. Another one, we make this point 3. Another one, we make here 4. Another one, we make here 5. If I said we calibrate arithmetically, it means that we keep on adding a constant number to that which precedes to get the next that succeeds. What is that we keep on adding? The scale. What do we start with? The scale. Therefore, to calibrate arithmetically, we start with the scale we got as the first term and keep on adding the same scale as common difference. That is what I mean when I say we calibrate arithmetically. Now, let me calibrate this axis, both the negative x-axis and the positive x-axis. Don't forget that though this negative x was used to find a scale, that scale applies to the entire x-axis. Let's watch. That is the calibration. -1, -2, -3, -4, -5. That is for negative x. Then you have +1, +2, +3. I hope you know what really happened. From here to here is 1. If from here to here is another 1, it means that here is 2. From here to here, another 1. That means here is 3. That is how it is done. And the calibration is done arithmetically. Let us now calibrate the y-axis. In like manner, we recall that every interval on the y-axis corresponds to 4 units. That is 2 cm. From here to here is that 2 cm. What does this interval, that is, what do these 2 cm represent? It is 4 units. Remember, that's what we got when we did calculation for our scale. That is also what we stated when we came to stating the scale. That means that from here to here is 4. Whatever y represents, if y represents mass, from here to here will be 4 grams or kilograms or other units or subunits of mass. So from here to here is 4. From here to here, another 4. That is 8 now. From here to here, another 4. That is 12. In that manner, along the entire y-axis. Let's see it. What you see next is the calibration of the y-axis. See it, -4, -8, -12, -16, and so on in that manner. The same thing is applicable to the upper region, that is the positive y subaxis. Let's see it. Yes, that is 4, 8, 12, 16. Please, when do we stop calibrating? It is when we reach or cross the highest value on the axis. Anyway, even if we cross and there is still space along that axis, it is recommended that you continue to calibrate until the end or near the end of that axis. The reason is also because we could have emergencies. It is possible for us to use other values which are not in the table to calculate either slope or intercept, as the case may be. Therefore, it is recommended that you keep calibrating until the end or near the end of the axis, even if you have reached or crossed the highest value on the axis. And now, checkpoint number C, it says, draw a straight line and calibrate it if a chosen scale is A, 2 cm, represent 5 units. The summary is here. B, 2 cm, represent 2 units. That's the summary. C, 2 cm, represent 0.4 unit. D, 1 cm, represents 0.1 unit. And E, 1 cm, represents 1.5 units.